All right, this one wants us to factor out the greatest common factor. No problem. And, well, there's no, just looking at the letters first, and I don't know why I'm looking at the letters first, just because I see the x to the power of 8 and x to the power of 5, but this last term, this positive 14, does not have any x's that would be like factors or common factors in this one. So I'll still show the factorization on this, right? So I start with 4x to the power of 8. 4x to the power of 8, and 4 splits up into 2 times 2. Okay, that's not too extensive. And then we got the 8x's, 4, 5, 6, 7, 8x's. And again, I'm just showing that there's no x's that are common with all three terms. And we got the 2x to the power of 5, so I'm going to expand this one as well. 2x to the power of 5, and I did split those up, or space those on purpose. 5x is there in purple, and then the 14 would just split up into, I'll say 2 and 7 right there. Again, that's more for convenience. So when I factor out the greatest common factor on this one, we got to figure out what that is first, and I just need any factors that are common. It has to be common with all three terms, not just 2. It has to be common for all three terms, and the only thing that I see that is common with all three is the 2. So that's the greatest common factor of 2, and then we're going to rewrite those three terms with whatever was left over from this factorization, right? So you still got some addition between those. So the 4x to the power of 8, what was left over? You'd have the 2 and the 8x's. This middle term here, we have only the x's left over, and there were 5 of those. And the 14, all that was left over was the 7 right there. So this would be considered factored with the greatest common factor.